Hello and welcome to Bizuz. In this video, we will be solving the CAIE past paper for A Level Mechanics M1 for the year October-November 2020, variant 42. Course code 9709/42. Question number 1 of this question paper says two particles P and Q of masses 0.2 kg and 0.5 kg respectively are at rest on a smooth horizontal plane. P is projected towards Q with speed 2 meter per second. A. Write down the momentum of P. Now this question holds 1 mark, so let's first understand the whole question. So there are two particles moving on a smooth horizontal plane. So let this be the smooth horizontal plane and let these two particles P and particles Q. Now these two particles, particle P and particle Q, has masses 0.2 kg and 0.5 kg respectively. So the mass of P is 0.2 kg, therefore its weight is 2 newtons since W equals to mg. Similarly, the mass of Q is 0.5 kg, so its weight is 5 newtons since W equals to mg. Now they are at rest on a smooth horizontal plane. So this is the smooth horizontal plane and they are initially at rest, therefore their velocity is 0. Now P is projected towards Q. So P is projected towards Q in this direction with a speed of 2 meter per second. So the speed of P, the initial speed, is UP equals to 2 meter per second. Now we are asked to write down the momentum of P, of this P. Now we know that momentum P equals to mv, mass into velocity. Now we know the mass of P, which is given in the question, to be 0.2 kg, and the velocity of P is the speed, which is 2 meter per second. Therefore the momentum of P, pp, equals to mass of P into velocity of P. So the mass of P we know 0.2 kg and the velocity of P is 2 meter per second. So pp equals to 0.2 into 2, which is 0.4. Now its unit is kg meter per second because to find the momentum we multiply this mass with this velocity. Now the unit for mass is kg and the unit for velocity is meter per second. So when we multiply these two, the unit of momentum becomes kg meter per second. Therefore, now the momentum of pp is equal to 0.4 kg meter per second, and this is the answer to this part of the question. Now for the second part of the question, B, it says after the collision, P continues to move in the same direction with speed 0.3 meter per second. Find the speed of Q after the collision. Now this question holds 2 marks. So let's first understand the whole question. Now what happens is there is a collision. Since P is moving towards Q, P collides with Q. And after the collision, P continues to move in the same direction. So in this direction with a speed of 0.3 meter per second. So P, after the collision, P still continues to move in the same direction with a speed of 0.3 meter per second as given in the question. Now we are asked to find the speed of Q after the collision. So we are asked to find UQ after the collision. Now we know that momentum should be conserved. So using the rule of conservation of momentum, we know that momentum before collision should be equal to momentum after collision. Now momentum before collision is momentum of P before collision plus momentum of Q before collision, and for after collision, momentum of P after collision plus momentum of Q after collision. Now we know that momentum is equals to mass into velocity. So before collision, the velocity of P was 2 meter per second and Q was not moving, it was at rest, therefore its speed was 0. So there was 0 momentum of Q before collision. So we can write before collision the momentum of P is mass into velocity 0.2 into 2 plus momentum of Q was 0.5, which is its mass, plus into 0.5 into 0, which is its velocity, as it was not moving at that instant. Now after the collision, the momentum of P is mass into velocity. Now the velocity has changed from 2 to 0.3, so we have 0.2 into 0.3 plus the momentum of Q after collision, which is 0.5 into UQ. 0.5 is the mass of Q and UQ is the speed of Q after collision. Now here 0.2 into 2 is 0.4 equals to 0.2 into 0.3 is 0.06 plus 0.5 UQ. Now UQ is equal to 0.4 minus 0.06 divided by 0.5, which is 0.68 meter per second. Therefore, the speed of Q after collision, UQ, is equal to 0.68 meter per second. And this is the answer to this question. Question number 3 first shows this diagram and says a block of mass mkg is held in equilibrium below a horizontal ceiling by two strings, as shown in the diagram. One of the strings is inclined at 45 degrees to the horizontal, and the tension in this string is T Newton, as shown here. The other string is inclined at 60 degrees to the horizontal, and the tension in this string is 20 Newton, this one. Find T and M, the tension T and the mass of the block M. Now this question holds 5 marks, so let's first understand the question. For this, let's redraw this diagram here. Now it says that there is a block of mass mkg. So this is the block with a mass of mkg. So its weight is 10 m Newton since W equals to mg. Now it's held in equilibrium. So equilibrium, we know at equilibrium the summation of all forces in a given direction is equal to 0. Now one of the strings is inclined at 45 degrees to the horizontal. So this string is inclined at 45 degrees to the horizontal, and the tension in this string is given as T newtons. So this string has a tension of T newtons and is at an angle of 45 degrees to the horizontal. So this force, tension force, can be broken down to its vertical and horizontal component. Now first, its horizontal component acts towards the negative x-axis direction and is equal to T cos 45 degrees. And its vertical axis, or its vertical component, acts towards the positive y-axis direction and is equal to T sine 45 degrees. Now there is the other string which is inclined at 60 degrees to the horizontal, and the tension in this string is 20 newtons. So similarly, this tension force can be broken down to its vertical and horizontal component. So its horizontal component acts towards the positive x-axis direction and is equal to 20 cos 60 degree, whereas its vertical component acts towards the positive y-axis direction and is equal to 20 sine 60 degrees. So now we have broken down all these forces, T Newton and 20 Newton force, into its vertical and horizontal components. So we are asked to find T and M. Now to find T and M, we can simply use the equilibrium method, that at equilibrium the summation of forces at a given direction should be equal to 0. Now if we resolve first horizontally, that means the total force towards the positive x-axis direction should be equal to the total force acting towards the negative x-axis direction. Now the total force acting towards the positive x-axis direction in this case is 20 cos 60 degree, and the total force acting towards the negative x-axis direction is equal to T cos 45 degrees. So we can write T cos 45 equals to 20 cos 60 degrees. Now T equals to 20. Now cos 45 is equal to 0.707 and 20 cos 60 degrees is equal to 10. So we can write 0.707 T equals to 10. So T equals to 10 by 0.707, which is 14.14 newtons. Now we have found the value of T. Now we need to find the value of M, for which we can resolve the forces vertically. So resolving forces vertically means the total force acting towards the positive y-axis direction should be equal to the total force acting towards the negative y-axis direction. So here the total force acting towards the positive y-axis direction is equal to 20 sine 60 degree plus t sine 45 degree, and the total force acting towards the negative y-axis direction is 10 m. So we can write t sine 45 degree plus 20 sine 60 degree equals to mg, which is in this case 10 m. Now we know the value of t, so we can substitute the value of t here, but first we can use the value of g here. So we can write 0.707, which is sine 45, so sine 45 t, which is 0.707 t plus 17.32, which is 20 sine 60 degree. So 17.32 equals to 10 m, where g is equal to 10. Now this can be treated as equation 1. Now we can substitute the value of t into equation 1, this one. So substituting the value of t into equation 1, we get 0.707 into 14.14 plus 17.32, which is equal to 27.32. So 27.32 is equals to 10 m. Now m equals to 27.32 by 10, which is 2.73 kg. Therefore, we have found the value of m. So T is equals to 14.14 newtons and m equals to 2.73 kg. This is the answer to this question. Question number 4 shows this diagram and says the diagram shows a velocity time graph which models the motion of a car. The graph consists of 4 straight line segments. The car accelerates at a constant rate of 2 meter per second square from rest to a speed of 20 meter per second over a period of t seconds. It then decelerates at a constant rate for 5 seconds before traveling at a constant speed of v meter per second for 27.5 seconds. The car then decelerates to rest at a constant rate over a period of 5 seconds. Find t. And now this question holds 1 mark. So first let's understand the whole question, but before that let's redraw this diagram here. So this is the velocity time graph, so we should redraw it here, and this velocity time graph models the motion of a car. Now the graph consists of 4 segments, 1, 2, 3 and 4. The car accelerates at a constant rate of 2 meter per second square from rest to a speed of 20 meter per second over a period of t seconds. So from 0 rest, here the car is at rest, till the first t seconds, it travels at a constant acceleration of 2 meter per second square. So this is the slope of this velocity time graph is the acceleration, which is 2 meter per second squared. Now it then decelerates at a constant rate for 5 seconds. So for 5 seconds it decelerates at a constant rate here, then, and it stays at that constant speed of v meter per second for the next 27.5 seconds. Finally, the car decelerates to rest at a constant rate over a period of 5 seconds. So from V, capital V, to 0, it takes 5 seconds. Now we are asked to find t. So this t. Now we know the acceleration, we know the final velocity, we know the initial velocity. So we can simply use the formula for acceleration. So acceleration equals to final velocity minus initial velocity by the time taken. So that can be derived from the equation v equals to u plus at. So this t is the time taken, u is the initial velocity, v is the final velocity, and a is the acceleration. So now we are asked to find the t, so we can write. So here the known parts are, we know that the final velocity is 20 meter per second, the initial velocity is 0, the time taken is capital T, and the acceleration is 2. So we can substitute all these values into the equation. We get 20 equals to 0 plus 2t. So t equals to 20 minus 0 by 2 seconds, so which is 10 seconds. So t equals to 10 seconds. Therefore we can write that t equals to 10 seconds, and this is the answer to this part of the question. Now for the next part of this question, the overall question remains the same. We say that given that the distance traveled up to the point at which the car begins to move with constant speed is 1/3 of the total distance traveled, find v. Now this question holds 4 marks. So let's first understand the whole question. So for this, let's redraw this diagram. Now it says that given that the distance traveled up to the point at which the car begins to move with constant speed. So the car begins to move at constant speed is this portion. So the distance traveled up to the point at which the car begins to move with constant speed is this whole part, marked by red, is 1/3 of the total distance traveled. So this is the total distance traveled. So this is 1/3 of the total distance traveled. Now we are asked to find V. So what is the total distance traveled? This whole thing, the red plus blue area. Now equating this information here, we know that total distance traveled is equal to 3 into distance traveled before constant speed. Now the total distance traveled, to find the total distance traveled from the velocity time graph, we can use that area under the velocity time graph is actually the distance traveled. So the total distance traveled will be the area under the whole graph. Now this portion is 5 seconds, so this is t plus 5 seconds, and this time here is 27.5 seconds. So this is marked as t plus 32.5 seconds, and this part is 5 seconds, so this is marked as t plus 37.5 seconds. Now to find the total distance traveled, we can break this diagram into different parts. So the first part here is a triangle, so we can find the area of triangle as half into base into height, where the base is t and the height is 20, so half into 20 into t, plus this part is a trapezium. So area of trapezium is half into a plus b into h, where half into a is 20, b is capital V, into h is t plus 5 minus t, which is 5. Now for the other part, this is a rectangle and this is a triangle, so we could use the formulas for area of a rectangle or a triangle, but in this case a triangle and a rectangle makes a trapezium, so we could use the formula of a trapezium, which is half into a plus b into h, where a is this 27.5 seconds, b is this 27.5 plus 5, which is 32.5 seconds, and the height is capital V. So we have half into a 27.5 plus b 32.5 into V. This should be equal to the distance traveled before constant speed into 3. So 3 into the distance traveled before constant speed is this area under the red portion, which is the first two terms here. So we just copy the first two terms here. Now calculating this, so half into 20 into t, where we found t previously, which is 10. So calculating t, equating t to be 10, we get this to be 100 plus 50 plus 2.5 V from here, as half into 20 into 5 is 50, and half into V into 5 is 2.5 V, plus 27.5 plus 32.5 is 60. 60 into half is 30, so we have 30 V is equals to 3 into 100 is this one, plus this is 50 plus 2.5 V. Now here we have 100 plus 50 plus 2.5 V. Here we have 3 times that thing, so we could just make it 2 times 100 plus 50 plus 150, or we could break it down. So we have 30 V equals to 2 into 100 plus 50 plus 2.5 V. So 3 into the same thing minus the same thing, we get 2 into 100 plus 50 plus 2.5 V. Now this could be written as 30 V equals to 200 plus 100 plus 5 V. Now we could bring the terms with V on the left hand side, so we get 30 V minus 5 V, which is 25 V equals to 200 plus 100 is 300. Now V equals to 300 by 25, which is 12 meter per second. Therefore the capital V is 12 meter per second. Answer. Question number 5 says a particle is projected vertically upwards with speed 40 meter per second alongside a building of height h meter. A. Given that the particle is above the level of the top of the building for 4 seconds, find h. Now this question holds 4 marks, so let's first understand the whole question. So there is first a particle that is projected vertically upwards with a speed of 40 meters per second. So let's have a particle that is projected vertically upwards with an initial speed of 40 meters per second. So u is equal to 40 meters per second. Now, this particle is projected alongside a building of height h meter. So here we have a building of height h meters. Now, when this particle is projected, it first reaches the top of the building at time t1 seconds, and then it reaches the maximum height. At maximum height, its final velocity should be equals to 0. So it reaches the maximum height at time capital T. And then it starts to fall down. Then it reaches again, it stays at a height of h meters above the ground at time t2 seconds. So when it's coming down. So at t1, when it's moving upwards, it reaches a height of h meters above the ground, and then it reaches the maximum height at capital T, and then when it starts to fall, it again reaches a height of h meters above the ground at time t2 seconds. Now, it is given that the particle is above the level of the top of the building for 4 seconds. That means t2 minus t1 should be equals to 4 seconds. So we are asked to find h, this height. What is the height of this building? Now first we can find the value of this capital T. But first we know that t2 minus t1 is equal to 4 from this statement that the particle is above the level of the top of the building for 4 seconds. So it stays above the level of the top of the building for 4 seconds, which is exceeds the level of the top of the building at time t1, and then again when it is falling down, it gains a height h meters at time t2 seconds. So it's t2 minus t1 should be equal to 4. Now we can first find the value of capital T, which can be found by using v equals to u plus at. Now the v is the final velocity. So we know that maximum height occurs when the final velocity v equals to 0 and time t equals to capital T for this reason, for this case. Now we can use the formula v equals to u plus at to find the value of t. Here u equals to 40 meter per second, v equals to 0 meter per second, t equals to capital T, and the acceleration is negative acceleration due to gravity, which is minus g, which is minus 10. So substituting these values into this equation, we get 0 equals to 40 minus 10t. So here we get t equals to 40 by 10, which is 4 seconds. So capital T equals to 4 seconds. Now we also know that the capital T is actually the midpoint of t2 and t1. So we could find the value of t1 as capital T is the midpoint of t2 and t1. So we could find t1 by the formula t1 equals to capital T minus t2 minus t1 by 2. So what we do is first we know the value of t2, and we know that t2 minus t1 by 2, so it is the half. So t2 minus this half is actually t1. Now t1 equals to capital T is 4, we found out here, and t2 minus t1 is actually 4 also, as it's given in the question. Divided by 2 is 4 minus 2, which is 2. So now we know that t1 equals to 2 seconds. So to find h is actually the distance or the height of the particle at time t1 seconds. So we could find the height s equals, by using the formula s equals to ut plus half at square, where s is actually the height h, a is the negative acceleration due to gravity, which is minus 10, t is t1, and u equals to 40 meter per second as it's given here. Now h, so substituting all these values here, we get h equals to 40 t1 plus half into minus 10 into t1 squared. Now h equals to 40 into 2 plus half into minus 10 into 2 square, as we know that t1 is equal to 2. So substituting the value of t1, we get h equals to 80 minus 20, which is 60 meters. Therefore h equals to 60 meter, and this is the answer. Now the next part of this question The overall question remains the same. Now, however, it says 1 second after the first particle is projected, a second particle is projected vertically upwards from the top of the building with speed 20 meter per second. Denoting the time after projection of the first particle by t seconds, find the value of t for which the two particles are at the same height above the ground. Now this question holds 4 marks. So previously we had this diagram when one particle was projected. So after this particle has been projected, 1 second later, 1 second after the first particle is projected, a second particle is projected vertically upwards from the top of the building. So from the top of the building with a speed of 20 meter per second, and 1 second later another particle is projected upwards with a speed 20 meter per second. Now denoting the time after projection for the first particle by t seconds. So the first particle's time is t. So we know that the second particle starts 1 second later, this one. So the time for the second particle is t equals to t minus 1, as it's 1 second later. Now distance traveled by the first particle above the ground could be calculated as s1, which is equals to ut plus half at square, where t is t. S1 is the height of the first particle, and a is the acceleration, negative acceleration due to gravity. U is the initial speed of the first particle, and the distance traveled by the second particle above ground from here is s2 equals to ut plus half at square plus this height of the building h, as it started from above the building. So s2 equals to u t minus 1, as the time for the second particle is 1 second later, plus half into a t minus 1 whole square plus h, which is the height of the building. Now we are asked to find the value of t for which the two particles are at the same height above the ground. So to be at the same height above the ground, s1 should be equal to s2. When two particles are at the same height, s1 equals to s2. Now s1 is this one and s2 is this one. So substituting, we get s1 equals to s2. So ut plus half at square equals to u t minus 1 plus half a t minus 1 whole square plus h. And previously we found h, so we could substitute the value of h. Now we have 40 t. 40 is the initial speed of the first particle in blue. So 40 t plus half into minus 10 into t square equals to 20 t minus 1 plus half into minus 10 into t minus 1 whole square plus 60. 60 is the value of h we found previously. And here the initial speed of the second particle is denoted as red u, and the initial speed of the first particle is denoted as blue u, here 40 and 20. Now we could write this equation as 40t minus 5t square equals to 20t minus 20 minus 5 into t square minus 2t plus 1 plus 60. Then this could be written as 40t minus 5t square equals to 20t minus 20 minus 5t square plus 10t minus 5 plus 60. So we could cut this minus 5t squares together. So bringing the terms with t on the left hand side, we could write 40t minus 20t minus 10t. So minus 20t minus 10t is equals to minus 20 minus 5 plus 60. So we could write here that 10t equals to 35. So t equals to 35 by 10, which is 3.5 seconds. Therefore, the value of t for which the two particles are at the same height above the ground at time t equals to 35 seconds. And this is the answer to this question.
Follow us on social media: Facebook, YouTube, Twitter, Snapchat, Instagram, and LinkedIn. So, don't be late. Enroll to your desired courses and let Bizuz be the guide to your dream grades.